Welcome back. This is the second video over the endocrine system, chapter 13. In our last video, we were talking about direct gene and second messenger systems as far as how hormones affect their target cells. In this one, we're going to start looking at what actually causes a hormone to be released or stop being released from the gland that secretes it. You'll find this information on this slide under the large picture where we looked at the second messenger system. So our topic is control of hormones. Control. And when we think back to what we spoke of previously in this class, what ultimately is really controlling our body, aside from the nervous system, and now we know the endocrine system, is the process of negative feedback. We have a set point. When we get above the set point, something happens to bring our bodies back to the set point. And conversely, when we dip down beneath it, something happens to bring our body back up to the set point. So negative feedback works in our body, and it regulates pretty much all hormones in our body in regards to their presence or absence from the blood. So as we mentioned in the first video, hormones travel throughout our body in the bloodstream. So how much of a hormone is in the blood, that's controlled by negative feedback. Once again, with negative feedback, most homeostatic mechanisms in our body operate using negative feedback. Only a few with positive feedback, where our body processes are actually sped up, like in labor or childbirth or blood clotting. So, what's causing hormones to be released from their gland or secreted from their gland varies. It could be one of several things. Some of these things could be things inside of our body or things outside of our body that would cause a hormone to be released. In quite a few instances, we talk about negative feedback. We go away from the set point and then coming back to the set point. What's actually causing our body to return to the set point is the hormones themselves that are released. So hormones are not in the blood. They're released in the blood. The gland that they came from detects that they're now in the blood, and then it stops releasing the hormones. So we're going to look at an example of that here briefly. But before we do, we're going to be looking at this graph. I'm going to come back to this graph on several occasions in the next few slides here. You do not have this one in your notes. I just wanted to once again point out the graph with negative feedback. We start at a set point, we go away from the set point, something happens to our body to return back to it. And conversely, in the negative direction, we go away from the set point and then return back to it. This slide you do have in your handout. This one is also under the large picture of the second messenger system. So, endocrine gland stimuli. What is actually stimulating the endocrine glands to release their hormones? This happens from one of three things. A hormonal stimulus, a humoral stimulus, and a neural stimulus. These are the things that actually cause hormones to be released. To clarify a few things first off before we get going, a hormonal, that means a hormone. Humoral, that is referencing a fluid, and neural would be referencing the nervous system. The most common way hormones are controlled in regarding the release from their glands is hormonal stimuli. Hormonal stimuli is when one hormone secreted by a gland, its target is another gland, and that gland will in turn release another hormone. So it's a hormone that causes a second hormone to be released. That's hormonal stimuli. The example we're going to be talking about in this presentation regards the hypothalamus and how it works with the pituitary gland. Hypothalamus, it secretes a hormone. That hormone stimulates the anterior pituitary gland. Once stimulated, the anterior pituitary gland secretes its hormones, and then those hormones will go to their own respective target or organ. This image you do not have in your notes as well, but to kind of illustrate the deep relationship between the hypothalamus and the pituitary gland, we probably should revisit their locations in the brain. We can see the hypothalamus right here. It's on top of the brain stem, part of the diencephalon, and the pituitary gland is directly beneath it. So this kind of hopefully gives you a little bit of an idea of how close they really are, and strengthens the relationship they have working with one another. This image off to the left side of your screen you do have in your handout. You'll see it alongside two others. It's the leftmost of those three images. This one is showing us a picture representation of hormonal stimuli, which is a control of hormone release. We were speaking just a moment ago about the hypothalamus and pituitary gland. Recall the hypothalamus, it's right on top of the pituitary gland. So how this operates is the hypothalamus, it releases a hormone. That hormone goes right here to the pituitary gland. This stimulates the pituitary gland to release its hormones. And just to kind of give you a heads up, the pituitary gland, it secretes 6 different hormones. Right here we see just 3, one going to the thyroid gland, one going to the adrenal cortex, and another one to the gonads. So once the hormone reaches the pituitary gland from the hypothalamus, the pituitary gland will release its hormone. Those hormones will go to their target organs, causing these target organs to release their hormones. So it really is kind of like a domino effect almost with this one. Let's take a look at how this relates to negative feedback. We're looking at how much of this hormone is in the bloodstream. All right. So if there's not enough of this hormone in the bloodstream and the hormone is needed, we are moving away from the set point. All right. We need it. It's not there. We're moving away from the set point. So the lack of this hormone in the bloodstream is detected by the hypothalamus. The hypothalamus will execute a corrective action. It will release a hormone to stimulate the anterior pituitary gland to release a second hormone that goes to the thyroid gland, in the example I'm using here, to release the hormone that is needed. Once this gets into the blood, we start moving back towards our set point. The second ways hormones can be released from their glands is through humoral stimuli or a fluid. And in this case, blood is our fluid. So we're looking at how blood levels change and how those changes causes glands to release their hormones. In this one, we're going to be talking about calcium. Calcium is needed in our blood, and it's stored in our bones. We know that our bones are made up of calcium. That's the hard deposits on our bone. So to kind of explain this one right now, calcium, it is needed in our blood. When there's too much calcium in our blood, we take the excess calcium and we store it in our bones. Opposite of that, when there's not enough calcium in our blood, we remove calcium from our bones and put it back into our blood. So our bone density, it can increase, it can decrease. It depends largely on how much calcium currently is in our blood, and do we need more of it or do we have too much of it? The example we're going to be looking at revolves around the parathyroid glands and blood calcium levels. This image that you are looking at on the screen here is the middle of the 3 on your handout. And it is showing us the parathyroid glands, which are these little yellow dots right here. There's 4 parathyroid glands, and the hormone they release, PTH. And it's also illustrating what's causing this PTH to be released. We can see up here that there's a capillary, which carries blood, and in that blood there's calcium. And when the calcium is too low, the parathyroid glands detect that, and in turn release parathyroid hormone. Parathyroid hormone would then go to the bones, cause the bones to release calcium, raising the blood calcium level. Once blood calcium levels are increased, PTH is no longer released from the blood. So let's take a look at that in regards to negative feedback and this graph. Our set point would be however much calcium we should have in our blood at any given point. If there is not enough calcium in the blood, so we're looking at this region of the graph, if there's not enough blood calcium, then the parathyroid hormones will detect that. They'll release parathyroid hormone, which in turn would cause bones to release calcium into the blood, meaning that there's more and more calcium going into the blood. We're back to our set point. Once we're back to the set point, the parathyroid glands would detect that calcium levels in the blood is normal, and it would stop releasing PTH. The last way hormones can be released into the bloodstream is controlled by nerves. So nerve stimulus can release hormones into the blood. The example we're going to use to illustrate nerve intervention is going to be through the sympathetic nervous system, which once again was the fight or flight system of the body. So let's take a look at that picture. Once again, you have this one in your notes. This is the third one, so it's the most right picture on your paper. And it does show a nerve connecting to the adrenal medulla, which is part of the adrenal gland. Now recall, our body is normally kept in a calm state using the parasympathetic nervous system, but when we detect danger, like we saw in many of those videos, that is a nerve response, and our nerves send out information to our organs to change function, to do something to keep us safe, to run away, either fight or run. In this case, an impulse is sent to the adrenal medulla of the adrenal gland, which in turn causes the gland to release catecholamines. We would know catecholamine as adrenaline. Adrenaline is an example of a hormone. Adrenaline would cause our body to speed up, which would be the result of this gland releasing that, speeding up, to keep us safe. And once danger is no longer detected, we go back to a calm state. We're back in a parasympathetic setting. Let's take a look at negative feedback graph and tie it back to our example here. Normally, our set point for this would be calm, normal, parasympathetic nervous system. But when we deviate from that or go away from it, it's a result of an increase of this hormone, adrenaline. So adrenaline goes into our body, we go away from it. Now we're way out here. How do we get back to the set point? What's controlling how we get back to the set point? That would be a nerve intervention over here. Nervous system no longer detects danger. It sends an impulse to the adrenal gland saying, hey, we no longer need adrenaline, stop pumping it out. The adrenal gland stops pumping out adrenaline, and we return back to our set point with the parasympathetic nervous system. And lastly, just to recap what we've been looking at in this discussion, we looked at 3 different ways that hormones can be released into the blood. One way a hormone can be released into the blood is by the stimulation from another hormone. So a hormone causes a hormone to go into the blood. The second one, changes in blood, a humor, a fluid, changes in blood, caused a hormone to be released into the blood. And the third one, nerves, caused a hormone to be released into the blood.